This is our 6th video for Chapter 3. This video is going to explain distributive property. The two vocabulary terms you need to define from the video in your notebook are the distributive property and equivalent expression. Be sure to label the section in your notebook as terms or vocabulary, number the terms, and define them from the video. First, let's talk about the distributive property. The distributive property shows how multiplication affects addition and subtraction. So what you're doing is you're distributing whatever's on the outside of the parentheses to all the numbers that are inside the parentheses. Think of it like dealing cards. The 2 is the dealer and it has to give cards to all the other numbers. So we'll start with the 2. It gives a card to 6x, gives a card to 3y, and gives a card to the 7. Then what we're doing is, since we have parentheses, it's going to be multiplication. So if we have 2 times 6x, that gives us 12x. Then 2 times negative 3y gives us negative 6y. And 2 times positive 7 gives us positive 14. So this is an equivalent expression or an equivalent equation for 2 times parentheses 6x minus 3y plus 7. Let's look at another one. So we have 7 times parentheses 9x minus 5y plus 4 close parentheses. Again, the number on the outside, you have to multiply it by every number on the inside. So we'll have 7 times 9x, 7 times negative 5y, and 7 times 4. So we'll do 7 times 9x first. So that is, erase. That is 63x. Then 7 times negative 5y gives me negative 35y. And 7 times positive 4 gives me 28. So the equivalent expression is 63x minus 35y plus 28. Pause the video and try these 3 in your notebook. Be sure to label the section as exercises and number your problems. Equivalent expressions are expressions with the same value. They name the same number regardless of which number the variable stands for. The distributive property can also be used in reverse. When you use the distributive property in reverse, it's called factoring. Let's factor this expression. Yes, we could just add it together, but we want to break it into smaller pieces. So we're going to factor it. So to factor it, we want to find our greatest common factor. And we're going to do that by prime factorization. So I know 20 can be divided by 5 because it ends in a 0. And 20 divided by 5 is 4. 4 I know can be factored into 2 times 2. So my prime factorization of 20 is 5 times 2 times 2. 8 we know, because we factored this several times, is 2 times 2 times 2. Now, to get the greatest common factor of these, we see what they have in common. 2's there, and 2's there. So they both have 2 times 2 in their factors, so their greatest common factor is 4. And the way you would write this with the distributive property is you would have 4 on the outside, so it would be times which is what the parentheses are for, 5 plus 2. So that's your prime factorization of, or not your prime factorization, your equivalent expression or your factoring expression of 20 plus 8 is 4 times parentheses 5 plus 2. Let's look at another one, because I know this probably sounds kind of confusing. But remember, when you're factoring, you're just breaking things up into its smallest pieces. So we'll look at 42, that's not a 2, 42 and 30. Alright, I know 30 and 42 and 30 can both be divided by 3, because 4 plus 2 is 6, and 6 is divisible by 3. So we'll start with taking 3 out. So 42 divided by 3, 3 goes into 4 once, with 1 left over. 3 goes into 12 4 times, so that gives me 14. So that means I'm going to be able to take 2 out. 14 divided by 2 is 7. 7 is prime. Then go down to our 30. 3 goes into 30 10 times, which leaves me 10 can be factored into 2 and 5. So the things, or the common factors for these are 3 and 2. So our greatest common factor is 6, because 3 times 2 is 6. So our equivalent expression will be 6 on the outside times everything that's left on the inside. Pause the video and try these 3 in your notebook. On the last 2 slides, we were factoring regular expressions, meaning an expression that has no letters in it, nothing wonky going on. It was just straight numbers and operations. Now we're going to look at doing the same thing, only with an algebraic expression, meaning an expression that has both letters and numbers in addition to operations. So we're going to do the same thing we did on the previous slides. We're going to find the greatest common factor. So we have 27, 18, and 36. Alright, these are all divisible by 3. So that's the number I'm going to start with on all 3. 3 goes into 27 9 times. We know 9 is 3 times 3, so 27's prime factorization is 3 times 3 times 3. 18 divided by 3 is 6. 6 can be broken down into 3 and 2. 3 goes into 36 12 times. 12 is broken down into 3 and 4. 4 can be broken down into 2 and 2. So the things that these 3 numbers have in common, oh, I'm forgetting my x, is 3 times 3. So the greatest common factor of this expression is 9. So when we rewrite our equivalent expression, after we've done our factoring, done our reverse distributive property, 9 will be on the outside. Then everything that's left for each of the numbers we factored is what goes on the inside. So for 27 we have 3 and x, so that 3x is left there. 18 has 2 left, and 36 has 2 times 2 left, which is 4. Now, the reason that these symbols are pluses rather than the minuses we have here is it goes back to our original equation. In our original equation, we were adding these numbers. So when we rewrite it with the factorization and the reverse distributive property, they stay addition problems. The only reason we had multiplication was for the factoring, not the original equation. let's look at that again. So now we have 60 plus 48x. So we're going to do our prime factorization for these two numbers. So let's see, 60 and 48, I know there's going to be a 2 because they're both even, so we'll start with 2. 60 divided by 2 gets me to 30. 30 I know is going to have a 3 in it. With 10 left, 10 can be factored into another 2 and 5. So 60 is finished. 48 divided by 2 is 24. 24 will have a 3 in it. 24 divided by 3 is 8. 8 can be factored into 2 and 4 can be factored into 2 times 2. So what these two numbers have in common, we have 2, 3, and 2 again. So our greatest common factor is going to be 2 times 3 times 2. 2 times 3 is 6, 6 times 2 is 12, so our greatest common factor is 12. So that's what's going to go on the outside of our parentheses. So we have 12 on the outside. Forgot my x on 48. So we take whatever's left on the top, so all that's left on the top is 5. So that goes there. We take the plus from our original equation. Then we take whatever is left for the second number, which is 2 times x. So 2 times 2 is 4. 4 times x is 4x. So the reverse distributive property, or the algebraic factoring of this expression, is 12, open parentheses, 5 plus 4x, close parentheses. Now, pause the video and try these three in your notebook. Now let's look at a word problem. A summer job as an assistant camp counselor pays $6.50 per hour. How much does the counselor earn for working 8 hours? Now, this is something we should be able to figure out for mental math, but I'm going to go ahead and sketch it out for you so you can see the process that really makes this easy and makes it something you can do in your head. Now, rather than trying to do 8 times 65 or 8 times 650, we're going to break this apart using the distributive property. The way that would look is we'll have 6 times 8 plus 0.5 times 8. All right, so we know 6 times 8 is 48 plus 0.5 times 8, or half of 8, is 4. So 48 plus 4 is 52. So for the camp counselor job, for an 8-hour, they would earn $52. All right, so it's just a matter of breaking it up into smaller pieces that are easier to deal with. Go ahead and pause the video and try this word problem in your notebook. Check your understanding. Number 1, number sense. In the expression, parentheses 4 plus 5, parentheses times 7, what is true for 4 plus 5? A, is it a sum and a product? B, it is not a factor of 63. C, it is a sum and a factor. D, it is equal to 63. Number 2, error analysis. Who simplified 2 times parentheses 3 plus 5 correctly? Explain. Thomas, 2 times 3 plus 2 times 5. Brian, 2 times 3 times 2 times 5. For the following problems, write equivalent expressions. 3, 2 parentheses 4 plus t. Number 4, 5 parentheses x plus 3. Number 5, 4 parentheses g minus 9 plus 5h. Number 6, mental math. Rebecca pays $3.50 per gallon for 12 gallons of gas. How much in all did Rebecca pay for gas? Make sure you have everything written in your notebook correctly. Enjoy the rest of your evening, and I'll see you tomorrow.